Hello and welcome to today's geometry lesson. So today we are starting chapter 4, and in lesson 1, 4-1, we are talking about translations. So the first thing we're going to talk about are vectors, and we're going to try to do a separate vector unit, but these are just the basics of vectors, so make sure you get this down. It has some new terminology and things in here. So what is a vector? A vector is a quantity that has both magnitude and direction. It is directed by a segment or an arrow. So when we talk about a vector, we have different symbols. This symbol right here means a line. And then we have a symbol with one arrow on the end. That means a ray. And then we have a segment. Well, we also have a symbol with one arrow on the end, and this is your vector. So this is what a vector symbol will look like. All right, vectors, so initial points, so this is where it's starting at A, and then you can see it's going in the direction of B because this is where they have the arrow on the end. To name this, so it's starting at A and ending at B. So to name this, we would call it vector AB, and the symbol above it is going to have that one line on the top. So we have to make sure that you're paying attention to those little details. Another thing would be to call this vector V. So you could also call that vector V. Remember, we can name lines according to lowercase cursive. So our lowercase cursive with that mark above it means vector V. All right, how do we write these? So when we write ordered pairs, we have parentheses, and we're talking about things on a coordinate plane. You'll see this vector form is still in the same XY form, so we're going to go horizontal, then vertical, and we always start from that initial point, that start value. And instead of having them parentheses, so when they have these brackets around them, this is when we're talking about a vector instead of an ordered pair. So the component form of this vector, so the initial point is starting here at C and then going to D. And remember, we have to go in the direction of X first. We're going to go horizontal, 2, and then it goes up 3. So this would be component form of the vector CD. So the component form of vector EF, so the initial point is here at E, and we're going to go horizontal first, so 1, 2, 3, 4, and then down 1, 2, 3, so it's going to be 4, -3. So remember, we have the caret looking things on the end and not parentheses. All right, the length of a vector is another way of saying magnitude. So when they say magnitude, they mean it is going to have length. So what the length is from the starting point to the end point. And that length is always going to be the absolute value of that. So it is going to be a positive length. The direction. So we said that a vector has both magnitude and direction. And when we're talking about direction of a vector, it's always with the horizontal line. So if we look at this vector, AB, initial point to terminal point here, there's a horizontal line that makes it, and we always start from the horizontal line and go up counterclockwise, so that this is a 60-degree angle. So if we had a vector that was going here, we start at the horizontal and we have to go all the way around. So you'd have to add that 180 plus whatever this measurement is in here. So it'd be the whole thing, starting with this positive and coming all the way around. Okay, another way that we do read vectors is according to nautical. And so we might say that we're bearing north. So when you're bearing north, and then it wants us to go 30 degrees east. Well, east is going to be this way, so that would be 30 degrees. So now if we were saying the direction of this vector, the direction of this vector is now going to be 60 degrees. So sometimes in nautical, they're going to say bearing north 30 degrees east or bearing south 20 degrees west. So you just have to go in the direction north and then the direction they're saying east, and that's where they get that 30 degrees. All right, so transformers, transformations. So the transformation that we're going to be talking about is an individual toy parts that can be shifted about from a vehicle and device or an animal and back again. Okay, that's what gets it to be the transformer. So a transformation is a change in the position, the size, or the shape of a figure. The thing that's probably the most confusing is when we look down here at the bottom and we see the pre-image and the image. It makes complete sense when I talk about it right now and I say the pre-image, that is the original, the ABC. So the original, what we are starting with is what's called the pre-image. And then we go through a transformation, and then the transformation, the result, is called the image. Now that makes sense right now when we're talking about things, but a lot of times when we're doing problems and I say, what is the image? A lot of kids like to start with that as being the image, as the starting figure. But remember, the pre-image is the original figure. The resulting figure is called the image. So we say a transformation maps the pre-image to the image. So the first one we're going to talk about is a translation, which a lot of times you guys just talk about it being a slide. And that is a transformation that moves every point of the figure in the same direction, the same distance. So if we have a point A, B, C here, and I'm going to go through a transformation, I have to move this whole triangle. If I'm going to do this whole triangle, it's going to go down here to the left. Then I have to move every point so that A, B, and C all go along that. So it stays the same size and it goes in the same direction. So you can see that the pre-image, so here is the pre-image. This is where we're starting, is J, M, L, K. And we move it on a transformation and all the points move. So if I were to measure from J to J prime, that net distance would be the same from M to M prime. And notice when we have the image, so this is the resulting image, has primes on it. J prime, M prime, L prime, K prime. That's how we can tell the difference between the pre-image and the image is the primes. All right, so is this transformation a translation? So did they slide from the blue figure to the red figure? And that answer would be no. I could see some of you saying, well, that's a reflection. You're right, it is a reflection, but it's not a translation. And B is yes, all of the points have moved in the same direction and the same distance. All right, here is the translation rule that we use. So when you're talking about a translation rule, you have to start with X, Y, and then this is telling you in the direction of A, we're going to move this many points, and in the direction of Y, we're going to move this many points. And then these are the numbers that are usually filled in there, so like a -5 and a 2. So this is going to go left 5 and up 2. All right, let's try a sample. So in this one, we're going to take point F, and it looks like it's going to go to the right 5 and to the left or down 6. So it's like putting a 2 in here for X and a 7 in here. So the resulting image, so this is your pre-image, and the resulting image is going to be at 7, 1. So the resulting image after the translation is going to be 7, 1. All right, so this figure right here, we can take any figure on this. So if we want to describe the vector, so remember if we're talking about a vector, we're going to have those marks there instead of parentheses. And the pre-image, so this is the start, is the pre-image, and then we end up at the image. So use a vector to describe this. So I am just going to pick this wheel, And then I'm going to go to this other wheel. Okay, so remember, we have to go horizontal first so that we get this right. So this goes over 1, 2, 3, 4, and then let's see, 5, 6, 7, 8. So it looks like it's going horizontally 8. And now how many is it going? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we are going to the left 8 from the image. We are going left 8, so this should be a negative 8. And then we went down 10, so this should be a negative 10. Oh, wait a minute, we went to the right. That shouldn't be negative. Scratch that. We went to the right 8, which is a positive. And then we went down 10, so that should be a negative 10. Always remember to go horizontal, then vertical. All right, so this is just talking about translations along an image. And in this image, you can see that these two vectors are parallel to each other because of that line right there, and they are the same distance. So the translation, so that means it's going to go the same distance and the same length. A rigid motion, so something that is rigid means it is going to stay the same length and angle measure. So it preserves and has the same length and the same angle measure. So when we had this figure right here, and I think we translated it this way, the resulting image, if this was a 90-degree angle, this is still a 90-degree angle. If this was a 50-degree angle, this is a 50-degree angle. So it preserves that. Everything is going to stay the same. Is a translation an isometry? So when you take any kind of translation, and yes, it is. It preserves both of those things. Composition. Composition, especially when you're talking about science, is a mixture of things. So in math, typically it is a combination of 2 or more things. So a composition is 2 or more rigid motions stays a rigid motion. So if we take 2 things and combine them, then it is going to stay a rigid motion. All right, that should do it. So good luck on your online homework. So you're going to have online lesson 4-1. Wow, struggling here. A little too many S's there. But good luck on your homework in lesson 4-1.